Welcome to qnawire.
So now we'll work on problem 110 from chapter 20. In this problem, we're told that some years ago, a unique proposal was made to raise the Titanic. The plan involved placing pontoons within the ship using a surface-controlled submarine-type vessel. The pontoons would contain cathodes and would be filled with hydrogen gas formed by the electrolysis of water. It has been estimated that it would require about 7 times 10 to the 8th moles of H2 to provide the buoyancy to lift the ship. In part A, they ask us how many coulombs of electrical charge would be required. So we want to produce 7 times 10 to the 8 moles of hydrogen gas. So to produce these from the hydrogen ions, it would require 2 electrons and these two electrical charges can be converted to coulombs using Faraday's constant. And when we do this calculation, we get a value of 1.35 times 10 to the 14th coulombs. That's the charge that is required. In part B, they ask us what is the minimum voltage required to generate H2 and O2 if the pressure on the gases at the depth of the wreckage is 300 atmospheres. So now we have the reaction here of 2H2O producing O2 and 2H2. Now the EMF standard value for this is the half reaction for the oxidation of water is 1.23 volts, and for this hydrogen reaction it's 0, so it's 0 minus 1.23. So we get a value of 1.23 volts. Now we're told that the pressure, the total pressure, is equal to the pressure of hydrogen and the pressure of oxygen, which is equal to 300 atmospheres. But since we have a 2-to-1 ratio from this reaction, then the pressure of H2 is equal to 200 atmospheres, and the pressure of O2 is equal to 100. So now we can calculate the minimum voltage required to drive this reaction. So E is equal to the EMF, which is negative 1.23, minus 0.0592 divided by the total number of electrons transferred, which is 4. Then we get the log. We don't include H2O, but we include 100 for the pressure of oxygen and 200 for the pressure of hydrogen, which is squared because of the stoichiometric coefficient. When we do this calculation, we get a value of negative 1.33 volts. So this here is our answer, which means we need to apply to drive this reaction greater than 1.33 volts. So in part C, they ask us what is the minimum electrical energy required to raise the Titanic by electrolysis. So energy we know is equal to NFE. So the number of moles that we need is 7 times 10 to the 8th moles. We multiply by Faraday's constant and the amount of energy which is required, which is 1.33, and we get a value of 8.98 times 10 to the 13th joules electrical energy is required. In part D, they ask us, what is the minimum cost of this energy required to generate the necessary hydrogen if the electricity costs 85 cents per kilowatt hour to generate at the site? So this energy, which we just calculated, is 8.98 times 10 to the 13th joules. Our conversion between kilowatt hours and joules is 1 kilowatt times hour is equal to 3.6 times 10 to the 6th joules. And then we have $0.85 for every kilowatt hour. So joules cancels, kilowatts, hours cancels, and we're left with dollars, and the dollar value which we're given is 2.12 times 10 to the 7th, which to write out in common numbers would be 0. That would be $21 million that's required.